Have you ever wondered whether two groups like males and females differ significantly in your dependent variables? It could be anxiety, depression, or any psychological measures. If you are looking to statistically compare two groups, the independence amplitude test is the tool you need to know. And in this video, I will guide you through how to run it step by step in R. If you missed my previous video, where I covered normality checks, descriptive statistics, and correlation analysis in R, make sure to go back and watch that first to get the full foundation. This video is part of complete R tutorial series designed for beginners, intermediate learners, and students. So make sure to like, subscribe, and turn on notification bell to stay updated with every new lesson. Now let's jump into independent sample test in R and uncover what the data has to say. Okay, now we will see independent sample test. Before that, we have seen the descriptive statistics and also the correlation analysis on R. Now let's see independent sample test. An independent sample test helps us compare the average or the mean scores of two different groups. In this case, we want to know if there is a difference in anxiety scores between males and females. So the first step is converting gender variable to a factor. Let's see here data, dollar sign, and here gender. Data is the name of our data set. We already defined that. So it's an object in our data set in R. So data means it represents this the social media use and the mental health, the locations, everything is here. So we already defined that in previous video. The other is gender with dollar sign. That represents this dollar sign represents how we tell R which column we are talking about. So data with dollar sign with gender means the gender column in the data set. So we are telling R to refer to the gender column in our data set. And this is an assignment arrow. Almost, I think we are familiar with that. In R, we use this to say store these results in this variable. It's like an equal sign, but pointing left. The other is as factor here with function. There is parenthesis function. This function always have parentheses at the end. This one converts a variable into something called a factor in R, which is how R handles categories like male and female. So this line is making sure R treats gender as a categorical variable. The other is filtering data to males and females only. We don't want others group because independent sample test it compares two groups, as you know, two categorical variables, male and female. We are doing that. So here to filter, we created subsets data. You can rename that according to your interest. It means we are creating a new dataset called subset data, and the result will be saved here. And here there is subset function. Look here, there is subset function. Here there is parenthesis. This function lets us choose only certain rows inside the parenthesis. The first part is our data. Here this is our data. And the second part after the comma is that shows gender with percent in percent like that. This means is in. And there is also C in the function in the parenthesis. That means C, male, female. It creates a vector or a list with male and female. So this says keep only the rows where gender is male or female. So we created a subset of the data, and this keeps only the rows where gender is male or female. And the other step is running the t-test, and we chose the Welch test. Here, t-test result and this sign. We are saving the test result into a variable called t-test result. So this t-test result saves this whole t-test analysis. There is t-test in the parenthesis. Place parenthesis indicates function in R. So inside the function, there is anxiety total with here anxiety total, and look this sign and gender, and this sign, this tilde, it's a way of saying by. We are saying that anxiety score by gender. Compare anxiety score by gender. And also here there is data is equal to subset data. It tells R to use our filter data. Our subset data means here. So to use our filter data, and var equals false, it tells R not to assume equal variances between groups. This is called Welch's t-test, and is safer if sample sizes or variances are different. In our case, variances are not different. We already checked by Levine's test in our previous videos. You might remember when we are doing that on spaces and theta. But our sample size are not equal. So to be on the safer side, better to use it false rather than true. If the sample size and the variance are equal, you can make it true like this. And we print the t-test result. Let's print it. Let's run the test. Select all and run the test. Okay, let's interpret the results from our independent sample t-test comparing anxiety scores between males and female. Let's begin from the bottom part. We see that the average anxiety scores for female is around 7.0102, and the mean anxiety scores for male is around 6.51. This means, on average, females in our sample reported slightly higher anxiety than male. The other key statistics is here there is t-test, degree of freedom, and p-value. So more importantly, look at the p-value, which is 0.01882. Because this p-value is less than 0.05, we consider this is statistically significant difference. In simple terms, the difference we see is probably not just due to random chance, and that is statistically significant. The other is 95% confidence interval here. So the 95% confidence interval for the difference means is from 0.08 to 0.93. Since this range also does not include zero, it supports the conclusion that there is a real difference in anxiety scores between male and female.